So today we will discuss about the question longest path in a matrix. Now in the previous video we have seen the brute force approach of the same question. If you haven't watched that video, I would highly recommend you please click on the I button on the top corner and first watch that video. That will help you to understand this question in the better way, because today we'll discuss about the dynamic programming approach for this question. So unless you will understand the basic brute force approach and why we need to use the dynamic programming, it will be difficult for you. So please check out that video first and then we'll start this video. So I hope you have watched that video. Now let's start to the problem. What is the problem is we are starting from the first node of the matrix, which is 0, 0. Now from any node you can take two directions. Either you can go right side or you can go the down side. When you can go, whenever next node value is greater than the current node, then only you can go. All right. You need to figure out the longest path from the starting node. That is the problem. Now we have discussed the brute force approach in the previous video. Let me show you. This is the code we have written. What we were doing is, if we are calling this method find longest path, okay, and these are the two base conditions we have written here. Okay, now this is the once we reach to the last node of the matrix, then just return 1, because that is the one node. So that means one length we got. So now whenever we are not in the valid index, whenever the index I and j are not valid, we cannot return some valid value, right? So length will be 0. So why we are returning 0? Because not valid, so length will be 0, right? Okay, so this question we understood. Now what we were doing is, we were taking one result variable and we are going for the right side based on the next node value. If it is greater, we will go to the right side. Similarly here also we are going to the downside if that is greater. Now what problem we were having with this approach? Problem is nothing. This particular algorithm will take a lot of time, that is exponential time, because we are calculating the same problem again and again. That is known as the overlapping subproblems. So we will try to overcome these things with the help of dynamic programming. Okay, so what dynamic programming says is, why, hey, once you got the answer for particular index ing, why you are calculating it again? Just store it somewhere. Okay, so I'll use the technique which is known as the top-down approach with memoization. Okay, so memoization is nothing but, I'll take one more matrix. Okay, let's say the store or caching we are doing. Okay, so here I'll take the same size, which is the row and column. All right, I'll run the loop. Oh, what error we are getting? 1 second. Cannot specify an array dimension after. Oh, sorry, that should work now. Yeah, so you need to run I0 I less than row. Why we are doing this thing? Because I just want to initialize the cache memory with -1, so that we will know, hey, we haven't calculated the answer for this particular ing. So ing, that will be -1. Okay, so what we are doing is, we are not doing anything. We are just taking one cache which is used to store the data. Okay, which is used to store the data, and so we will not recalculate the problem. We will not calculate the data again and again. A lot of mistakes I did. Okay, right, now you just need to pass this cache along with our function call. Here also you need to take it. So int I, oh, cache, let's say. Okay, so let me just minimize this one. Yeah, now here that is absolutely correct. Yeah, here one thing you can do, we are just returning one, which is fine. Here also we are not doing anything, we are just returning based on the code. Here what we are doing, we are calculating the logic for index I and j. All right, so here what one check I will do, if we have already calculated the longest path, okay, longest path starting from index I and j, which is stored in cache, just return it. Okay, so did you guys understand this or not? This is very important, because what we will do, we will store the answer of longest path from I and j in our cache array, cache matrix. So what I'll do, if cache of I and j is not equals to -1, okay, is not equals to -1, that means we have updated it somewhere. Just return it, do not calculate it for me. All right, what we'll say, hey, do not calculate it for me, just return it. Otherwise else come down, that means we haven't calculated it. So we'll just pass the last parameter here also. That's why you can see the compilation error. Okay, errors are gone now. Now here you are returning the result. What is this result? This result is nothing but the longest path when you are starting from I and j. So you need to store the result into our cache, because this is the only place where we will update the cache, right? We are not updating anywhere else, so this is very important. Here you need to store the result in your cache, memory. I hope you understood this thing. I just need to return the caching, so cache of I and j. All right, cache of I and j. This is the important thing which I need to return. Okay, let us try it. So we should get 7 again. See, we got 7. So here the time will be from exponential, we came to the polynomial time. Okay, because we are just going to one node only once. If we got the answer from that particular node, we are not going forward, we are just returning, hey, that is already solved, okay, do not solve it again. So that is the power of dynamic programming. Dynamic programming is nothing but storing the data somewhere and do not compute it again, because we got the answer already, so why to compute it again? That is very simple. But so people, I have seen people are very much afraid of the dynamic programming, but it is very easy technique. The only thing is you need to understand how things are working. You should be able to understand the concept without dynamic programming. Then only you can feel the problem, then only you can understand the problem. Okay, so yeah, we are good now. Thank you everyone. If you like my video, please share, like, share, subscribe.